such topic is called covariant return types. And here, what we're talking about is a different type of polymorphism. Actually, we're not even call it, let's not call it polymorphism. Let's just call it covariant return types, like it says here. Basically, we can change the return type of a method in a subclass as long as it is a derived class of the original subtype, or a subtype of the original type. And the easiest way to think through this and understand what I'm talking about here is to look at an example. And the example I'm going to talk about comes from this link right here, but I'll just bring it up in my editor so you can see it a little bit better. So anyway, what we're looking at here is another one of these animal examples. So we've got a class called wild animal. It has one method defined. We've got two classes that extend that. A lion is a wild animal and a Bengal tiger is a wild animal. And each of those know how to answer this question, who are you? They return a string to say what kind of thing they are. So this is not exactly a useful program, but it demonstrates this idea. We've got a second class here called zoo, which provides a method get wild animal. And then two classes extend that. A zoo that has to do with things that are in Africa and a zoo that has to do with things in India. And this is very boring because the only thing that are in our Africa zoo are lions, and the only thing in our India zoo are Bengal tigers. So if you called get wild animal on something which was constructed as an Africa zoo, you would get a lion. If you called it on an India zoo, you'll get a Bengal tiger. And if you call it on the base class zoo, you'll get the more general purpose wild animal. And where the covariant return types comes in is that get wild animal returns a wild animal in zoo, but it returns a lion in Africa zoo, and it returns a Bengal tiger in the India zoo. These are different return types than the original, but if we look back up here, they are classes that extend the original return type. So yeah, it still is a wild animal, but more specifically, it's a lion. And yes, it still is a wild animal, but more specifically, it's a Bengal tiger. And if we look down here at a little main method that tries this stuff out, we can see if we construct a couple of these zoo objects, specifically in Africa zoo and specifically in India zoo, we can ask each one for a wild animal and call its who are you method, and it should print out that we have what we have. And yes, the first one prints out a lion, the second one prints out a Bengal tiger, and it's perfectly happy doing that. Now, a couple of things that we can think about here. One is if we were to take the return value of the first and try to call this method on that object, we're going to have a problem. Why is that? Even though get wild animal existed in both of these classes, and the thing I'm returning, I know from the AF zoo is really a lion, I can't call the who are you method on an A because I've stored it as a wild animal object. And you might not have noticed up here that the thing in wild animal is different. The name of the method in wild animal is different than the name of the method in the other two. So we've got, we don't have a who are you method in the wild animal class. So this would not be allowed here. We can't do that. But we can do what we had originally because we know that the things coming out of the Africa zoo from Get Wild Animal, we know that it is a lion, not just a general purpose wild animal. So we know it has a who are you method. Does that make sense from what you've seen so far? The next thing that I'd like to think about here, and this is related to the first of those questions in that Google Classroom document, Well, this is a perfectly legal assignment here, right? So I can assign an Africa zoo to a variable of type zoo because this thing zoo is extends zoo, so it's also a zoo. If I try to compile it though, now that I'm referencing this get wild animal through a zoo object, the compiler doesn't know that this is actually going to be a lion object. So it can't call its who are you method. At runtime, we know that this would work because Africa zoos only provide lions, and lions have a who are you method. But as soon as we put it into this zoo object, we're restricted to only the things that zoos do. So it's now seeing get wild animal as returning a wild animal base class rather than specifically the lion class. Put this back the way I found it. So I think we've said what we need to say for you to be able to answer your first in-class question on this. You can do those now, or you can do them afterward, whatever you prefer. But I introduced this idea of covariant return types because it can be a useful type of thing to do. It probably would be more useful to us if we were to make this an abstract class that had a who are you method that's required and so on. So, oh, my dog just came in. All right. All right. This is a little different than what we did when we did our first examples with the different types of animals. Remember there, we stored the different types of animals in a single array or an array list, and then we were able to call methods on those, even though they were of the generic type. Here, we can't quite do the same thing because the who are you is not existing in both places. But it does give us this nice advantage that if I know I have an Africa zoo, I know that the thing coming back is a lion. So assuming lions had a bunch of other methods, I could call all the lion methods here because I know that that object is coming back as that type. This is not just a Java construct. This is a general programming, object-oriented programming concept that I think is important for us, at least to have seen, even if we haven't really had much of a chance to make use of it. All right, if I hear no questions on that, I will jump ahead to the next